dipole moment. Dipole moment gives the strength of dipole to us. It is calculated through the product of the magnitude of any of the charge and the separation between them. So for the students who are new, they have their first class today. If you have plus q and minus q with you, with certain separation between them, that forms your dipole. That is known as your dipole, a set of a positive charge and a negative charge. But remember, the magnitude should be same. You cannot take plus 2 coulomb and minus 4 coulomb with you and call it a dipole. If it is minus 4 coulomb, it will be plus 4 coulombs only. And remember the direction also. One more thing is there. Who is going to tell? Hiba, you tell me, what is the SI unit of dipole moment? Hiba? Yes, Hiba, you can even write me in the chat box. I'll read it out. What is the SI unit? And all those who don't remember the SI unit, you can easily figure out from the formula. The formula is Q means the charge multiplied by distance. So what is the SI unit of charge? What is SI unit of distance? Just multiply that. Yes, Hiba, it's correct. It will be coulomb meter. It will be coulomb meter only. Coulomb meter will be the SI unit. Coulomb is for the charge and meter is for the distance. All right. So just note down this question. Then we'll discuss it together. At least note down it. And all those who are able to calculate the dipole moment and answer me. The rest of you, please make it. This is your z-axis, positive z-axis, and this is negative z-axis, your y-axis and x-axis. So you don't have the separation directly given. You are given coordinates, and this is the origin. So use your previous knowledge of graphs if you are given coordinates where you have to mark the point. So only Krishna has submitted the answer. All right, let's discuss it then. Akifa, there's some error in your powers of 10. Just check it once again. It's not 10 to the power minus 3. Just check it once again. All right. So see, you have to calculate the dipole moment. What is the formula of dipole moment? P is equal to Q multiplied by 2A. Q means any of the charges, magnitude of any of the charge that you have, because the magnitude is same. 2A is the separation between the two charges. So yes, Fatima, the other Fatima, Fatima Munir, you tell me, what is the charge? Look in the graph that is given. What is the charge? Q. What should I write Q? Yes, Fatima. This is the graph that you have. See, plus minus you are not concerned with. You just have to take the magnitude. So Fatima, will I only write 2? Is the charge given 2? Will writing 2 be sufficient? 2 coulombs. Is 2 coulomb given to me? Yes, anyone else? Fatima, you tell me, what is the charge?
It's a 2 plus 2.
Not 2 plus 2. See, you have two charges in a dipole. One dipole's charge is plus Q, other one is minus Q. That forms your dipole. So you have to take any of the charge, means Q. If you are given, what are the charges given over here? You are given plus 2 millicoulombs and minus 2 millicoulombs. So plus 2 millicoulomb minus 2 millicoulomb. You can take any of the charges because the magnitude is same. Magnitude is 2 millicoulombs. Fatima was right that it will be 2. But you forgot the SI unit. You have to write all your symbols into SI unit. Millicoulomb is not the SI unit of charge. So you have to write it as 2 millicoulombs. So 2 millicoulombs means I have to convert it into SI unit. Milli means 10 to the power minus 3 coulomb. This is the charge you have to take, and this is how the charges have to be considered. Now, all of you write me in the chat box, what is 2A over here? Means what is the separation between both of the charges? Coordinate system is given. Let's see who gives the correct answer. What is the separation between the two charges? 2A. Okay, Krishna, tell me how. How did you get this answer?
It's the distance between 2 points, like so.
It is the distance between 2 points.
I'm like 5 millimeter, and then you convert into something.
5 millimeter you're getting from where? Yes, Krishna. This is your origin. This point is 0, 0, minus 2. So from your origin, this point at this, see, x equals to this 0 means x is 0. This 0 means y is 0. Minus 2 means z axis is minus 2. So you have to mark 2 millimeters from this. So from your origin to this point, the charge that you have, this becomes 2 millimeters. All right, this is how we use coordinate system. This 0, 0, minus 2 means all the unit that will be present on the z-axis, this negative z-axis will be minus. So it means it will have 0 at the origin, minus 1 millimeter at some distance, then minus 2 millimeter. This charge is kept. So from the origin, this distance becomes 2 millimeters. Then again, from this distance, means this is plus 2. This will also be 2 millimeters from the origin. Now look, 2 millimeters from the origin, 2 millimeters below the origin. Total is what? Distance between the two charges, 4 millimeters now. And Akifa, you missed your conversion. 4 millimeter is there, 4 centimeter is not given. All right, Akifa? So your, I think, answer, that's why there must be error. This separation is 4 millimeters, and 4 millimeters means 4 into 10 to the power minus 3 meters. Now tell me, is there any doubt till here? How we have taken the separation? Is it clear to all of you? Should I repeat it?
Clear, ma'am.
Clear?
Teacher, I didn't understand how you did X, Y, Z distance.
Distance? See, Fatma, your point is given as 0, 0, minus 2. This means the point is located at 2 units on which axis? On the z-axis. And we are able to identify it using this, because first one gives us for the x, second one for y, third one is for z. So mark 2 units on z-axis from the origin. 2 units what? What is the unit over here? Millimeters. So from the origin, your charge is kept, one charge is kept at 2 millimeters. You have figured this out. Then then we have seen that what is the separation or what is the coordinate of the positive charge. It is 2 units on z-axis again. So you again mark 2 millimeters on this z-axis. But what do we consider? While calculation of dipole moment, we see what is the separation between the two charges. So if you see total separation between both the two charges, from the origin one is 2 millimeters, from the origin other one is 2 millimeters. You take out total distance. This becomes 4 millimeters. And one, all right, Fatma, is it clear now?
You have to take the magnitude, not minus 2.
No, not minus 2. Minus 2 anyways you don't have to take. Whether it is charge, for charge also you don't have to consider. For this also you don't have to consider for the distance. Just take out any of the charge, means if you have charges as 2 millicoulomb or minus 2 millicoulomb, take 2 millicoulombs because you are not concerned with the charges. Then anyhow just try to look up what is the separation between the two charges, because you are not considering displacement or something, no, that you have to take negative charges. Even if minus 2 is given, it is like this in the coordinate. If the graph is drawn, this will be minus 1, this will be minus 2, somehow the way graphs are drawn. But you have to take out the magnitude. You don't have to consider the sign of negative. All right, so this total becomes 4 millicoulomb.
Yes, teacher. Thank you very much.
Okay. So P dipole moment is Q multiplied by 2A. So now this becomes easy. Charge is 2 into 10 to the power minus 3. 2A means the separation between the two charges is 4 into 10 to the power minus 3. That becomes 8 into 10 to the power minus 6. Now, writing this is not sufficient, because as we have discussed it in today's class as well as in previous class as well, the dipole moment, this is a vector quantity and it has a direction. So Kulsum only told us the direction today. What was the direction, Kulsum?
Right to left.
Right to left. Tell me in terms of
Negative to
positive,
positive.
negative to positive, correct. So
Okay,
I have
negative.
to move from negative charge, means I have to check which is the negative charge. This is the negative charge. So I'm moving from the negative to the positive charge. This is the direction of dipole, negative charge to the positive charge. Now see, I have to write down the direction as well. So which unit vector it is pointing to? I cap, j cap, k cap, minus I cap, minus j cap, minus k cap.
J cap.
J cap is for y axis. For z axis it is
K cap.
K cap. All right. So you have positive z axis, which means the direction will be K cap. If we reverse the charges, had the -2 been kept here and +2 would have been kept there, then the direction would have been in this manner, means pointing to the negative z axis. Then you would have written minus K cap. So right now you have the direction of the dipole as K cap. So this will define your complete answer. This will be K cap Coulomb meter. Clear to all of you? This is your final. All right. So just note it down, those who have not written, then we'll relate it with electric field. So yes, done, all of you?
Yes, ma'am.
All right. Let's relate dipole with electric field. Now you have two cases with you. One is axial line, other one is equatorial line. So you have to identify yourself whether the question is asking you in axial respect or in equatorial respect, because the questions will be easy. They will be providing you the values. You'll just have to put in the formulas. That will be easy. But the task is first to identify whether the line is axial or it is equatorial. So axial lines means what? If you have the dipole, like plus q is there, minus q is there, both of these are separated by 2a. So if this is the center of dipole, this separation will be a, this separation will be a. All right, this is the dipole that we have studied. Now see, if you are given any point on the axis of this, means this is the axis, if you produce it, this is the axis, and you are given any point on the axis of it, then you have to see all the respective cases of axial line. If I say I've given you point, let's say A, now what we'll see, electric field direction due to plus Q. So what is the direction for a positive charge? If this is your point A, this is your positive charge. Will the
Outwards.
outwards. So Fatima, you only please complete the answer. Will it be towards the right or left for because of positive charge at point A? Yes, Fatima,
Right.
try.
right?
Correct. It will be in this manner. See, this is your charge and you are moving away from it. This is your E plus Q. Now, Fatima, you only complete. For minus Q, where will be the direction?
Inwards.
Inwards, that is left or right?
Left.
Left, correct. So see, for negative charge, we move towards the charge. So this is my point. This is the charge. So I'll move towards the charge. This is the direction of electric field. Now, as we have discussed, if you have more than a single vector quantity with you, the principle that we use, what is the name of the principle? Yes, in the last class, we have done a principle for
Superposition principle.
superposition principle. Yes, so only Fatima has studied superposition principle. See, you have two charges with you now. And both of these two charges have their own electric field. Now, these two charges have the opposite direction. So the resultant electric field, whatever is the resultant electric field, will be given by vector addition of positive charged electric field and the negative charged electric field. This will be your answer. Now see, we don't know the separation from the point to both the charges. So let us just consider a random term. Let's say from the center of the dipole to the point is x. This separation is x. All right, this separation from the center of dipole to the point is x. Now our calculation will become easier. You will see how. So see, E plus Q, let us see what is E plus Q. How do we calculate the electric field? KQ divided by R square. So K is this. Q for positive Q, this is small q. Now the separation, if this total is x, this part was small a, what will be from here to here? What is the separation?
X plus A.
X plus a, good. So this will be x plus a whole square. This is your E plus Q. Similarly, if you have E minus Q with you, this will be KQ. Yes, Krishna, you only tell me. What will be separation from this point to this point? This.
X minus A.
X minus a. See, this whole is x. You have subtracted this x because you want this part only. So this will be x minus a whole square. The general formula of electric field was this, no? KQ divided by R square. This was the general formula of electric field for a point charge. So we are just taking the separation between the point and the charge. Now see, both of these vectors are directed in opposite direction. So you can simply subtract both of them when two vectors are anti-parallel. Anti-parallel means at a distance of 180 degree. Both of them are 180 degree separated. So it means you can subtract those two vectors. So your net electric field, this will be equal to, you have to take KQ x minus a square, means this term, x minus a whole square, plus, or basically we have to subtract it, minus KQ x plus a whole square. This is how we'll take the net electric field. Both are in opposite side. Now see, we can take KQ common from both of them. KQ is common here, KQ is common here. So see, electric field KQ can be taken out common. What will be left? X minus a whole square minus 1 by x plus a whole square. Is it clear till here?
Yes, ma'am.
All right. Now we just have to solve using our basic mathematics that we know. We can take the LCM. That is the best way to solve it. Electric field will be KQ. So this term will be x plus a whole square minus x minus a whole square divided by x minus a whole square multiplied by x plus a whole square. We have just taken LCM. The way you take LCM, we have just taken LCM for both of these terms. Now see, it is better to open these brackets. So electric field will be KQ. Now you can easily identify these are two identities. So x square plus a square plus 2ax. Now see, this has a minus sign. So it would have been x square, but with the multiplication of minus sign, this becomes minus x square. It would have been a square. With the multiplication of this minus sign, it becomes minus a square. And it would have been minus 2ax. Minus 2ax multiplied with this minus sign gives plus 2ax divided by, now see, divided by x minus a whole square, x plus a whole square. So x square gets cancelled, a square gets cancelled. We are left with 2ax plus 2ax. So 2ax plus 2ax, this gives kq. 4ax divided by ax minus a. This gives you x minus a whole square, x plus a whole square. We are left with here. Now, if you remember your identity, a square minus b square, what was that identity? A square minus b square.
A plus b into a minus b.
A plus b into a minus b. So see, you don't have a plus b, a minus b with you. Here you have a plus b whole square with you, a minus b whole square with you. So that's why you have a minus b whole square. So you can write your resultant electric field as kq 4ax divided by, you can write a plus b whole square, a minus b square as what? A square minus b whole square. This becomes x square minus a square to the power whole square. Is this clear how I have written this?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
All right. So see, q 4ax k divided by x square minus a square to the power whole square. Now what if I write q 2a together, then 2 is left from this 4a. This becomes 4aq, means I've written 4aq. kx divided by this whole term, x square minus a square whole square. What is q multiplied by 2a?
P.
P, which is the dipole moment. So now we have established a relation. This will be P 2k x divided by x square minus a square to the power whole square. 2 is the constant, k is the dielectric constant which we use, 9 into 10 to the power 9. P is dipole moment, x is separation from the center of dipole to the point, and a is the half of separation between the dipole. So this is your formula of electric field at axial point. Now see, this is valid if your x is comparable to a. Now if I tell you, we have one more thing in this which is known as ideal dipole approximation. Ideal dipole approximation. Under this ideal dipole approximation basically means that the x that we have taken means the separation from the point to the center of dipole. This is so much greater than the separation between the dipole. As in, the dipole is very small. If your dipole becomes so small, dipole was this, now your dipole is so small. So this separation becomes greater. Under ideal dipole approximation, your dipole's size is very small. Size is small means the separation between the two charges is very less. So x becomes greater than a because now a has shrunk, a has become very less. So if x is very, very greater than a, so x square minus a square becomes what? we can almost write it as x square only. It's like you have a very big number with you. You have 1000 with you and you're subtracting 1 from it. What will it be? 999. So you can write 999 approximately equal to 1000 only, no? Both of these are comparable. If from a very big thing you just subtract a very small thing, so it doesn't matter, we are approximating it, we are not writing it precisely. So x square minus a square can be written as x square. Now, if you have such a case where your dipole is very small, means you can find it out using the values that are given in the question. If you see x is very great and a is written in nanometers or millimeters or very small units, then you can say x is very, very greater than a. Then you are not required to use this large formula. What you can do, if this is equal to x square, you can write 2kpx divided by x square minus a square. This term as what? X square only. This term I have written it as x square. Now to the power 2. So this becomes what? It is 2kpx divided by x to the power 4. X will cancel this power and ultimately we are left with E is equal to 2kp divided by x cube. So if you remember, your electric field formula was what? E is equal to kq by r cube, r square. Electric field was inversely proportional to square of the distance. If you remember, we had plotted the graph also. We got the graph as hyperbola. Now see, here in case of axial field, it is coming, electric field is coming inversely proportional to cube of the separation. This is one more thing to be noted. And apart from this, direction of this axial point, if you have to calculate the electric field at the axial point, what you can do on axial line, the direction is same as that of dipole. Is same as that of dipole moment. It means I have charge minus q, I have charge plus q. The direction of dipole is from the negative charge to the positive charge, means in this direction. This is the direction of dipole. So if I have a point at A, electric field will also be in this direction. Whatever is the direction of dipole, that will be the direction of electric field. So I'm just repeating it once again. Electric field at this point A came out to be in two opposite directions. We used superposition principle. We took the resultant of the electric fields and we got this formula 2kpx divided by a square minus x square minus a square to the power whole square. For ideal dipole approximation, means if you have a dipole whose size is very small, then you can use this formula 2kp divided by x cube, and direction of axial line is same as that of the dipole's moment direction. So whatever will be the direction of dipole moment, take it same as the direction of electric field. Clear to all of you? Any doubts?
No, ma'am.
All right. So if you want me to repeat any part or you have any doubts, just let me know. Till the time, start noting it down. And wherever you get stuck, just ask me. This is your first derivation of class 12. Numericals do come from that part also, quantization of charge, Q is equal to NE. But derivation, this is your first derivation. Yes, done.
Yes, ma'am.
Yes, teacher.
Alright. Now see, that was the case of axial line, means whenever you have a point on the axis of the dipole, that then you have to keep in mind all these formulas and the ideal dipole approximation as well wherever required. Now electric field on the equatorial line. What is meant by equatorial line? See, this is your charge minus q, this is your charge plus q. Both of them are forming a set of a dipole. And from the center, let's say this is A, this is A. That's why we say the separation is 2A, no? If you are given a point on the perpendicular bisector of the dipole, like this point, C point that happened. Let's say this point is A, this point was B, this point C. Then you have to keep in mind this is the case of equatorial line. Means from this point you can see the perpendicular separation from here as well. This will be 90 degree, and let's say from the point to the center of dipole, again let's say this is some r. The way we have taken it x, in the previous case, let's say the separation is r. So r is again point and the separation from the point to the center of dipole. There it was axial, so this got expanded. Here it is equatorial, so it is on the perpendicular bisector of it. Now, direction of electric field. See, regarding the direction of electric field, for the negative charge, electric field will be directed towards the charge. Means electric field will be directed towards it, like this. Electric field will be directed towards the charge. This will be E minus Q. Electric field because of the charge negative. Now E plus Q, what will be the direction of electric field because of the positive charge? So because of positive charge, it will move away from the charge. Means in this manner, this will be the direction of the electric field because of positive charge. It is moving away from the charge. Here we were moving towards the charge. Is this clear? The direction is clear?
Yes, teacher.
Yes,
All
ma'am.
right. All right. Now see, these are the two electric fields that you have. Again, we have to apply superposition principle. If you have two vectors, the resultant is given by their vector sum. For the calculation of vector sum, what we can do, we can take this angle as theta, this angle as theta. This will automatically become theta because this is a parallel line. This I have drawn a parallel line, parallel to the dipole. And this is also theta. All right, I have taken some random angles on it. I have taken these angles just to solve it. So if you remember resolution of vectors, from your resolution of vectors, if you have a quantity A with you, and this is the angle theta. So yes, how do you resolve it? How do you solve it? Resolution of vectors. What will be this component?
A cos theta.
A cos theta. See, all those who have forgotten it, with wherever the angle is making with the axis, that we write it as vector along with cos theta, and the perpendicular to it, that becomes your sine theta. This becomes A sine theta, this point. This is A sine theta, this is A cos theta. Similarly, E minus Q, this is making angle theta. So this will give you the direction of E minus Q cos theta, and this will give you the direction of E minus Q sine theta. This was the angle theta, this was E minus Q. So this gave E minus Q cos theta, and this gave E minus Q sine theta. Simple resolution of vectors. Similarly, for this E plus Q, again with the angle at this axis, it is making E plus Q cos theta, and the perpendicular to it means in the upwards direction, it will be E plus Q sine theta. How will I write, how I have written this sine theta? This was E plus Q, this was theta. So this became E plus Q cos theta, and the perpendicular to it became E minus Q sine theta. Resolution is clear? Resolution of vectors?
Yes, ma'am.
Is it getting clear to all of you? Akifa, Fatima, Hamza, Hiba, Kulsum, Aisha? All right. Now see, we have resolved the vectors. So if you look in carefully, on your y-axis, E plus Q sine theta is directed upwards, E minus sine theta is directed upwards, means net electric field on y-axis, it is E plus Q sine theta and E minus Q sine theta. On x-axis, you have E plus Q cos theta and E minus Q cos theta. This is, we have resolved it. Now let us write the values of E plus cos theta and E minus cos theta, means E plus Q and E minus Q. So see, before that, in this triangle EAOC, this triangle, in this triangle AOC, for calculation of electric field, we have to know what is the separation between the point and the charge. We don't know the separation between the point and the charge. So what we can do, if you look at this triangle carefully, this is A, this is O, this is C. This is R, this was A. Can I get this? AC. Is it possible for me to get AC?
Yes, ma'am.
Using Pythagoras theorem. Pythagoras theorem, if you apply, AC will be equal to what? AC will be equal to AB square plus BC square under root. Means this side will be R square plus A square. So your separation of both the points from the charges, this will also be R square plus A square, means this. And this will also be under root R square plus A square. Separation of the charge and the point. Now calculation of electric field is easier. If I say electric field for the charge plus Q or minus Q or any field, just electric field, it will be K Q divided by. Now tell me what will come in the denominator.
R square plus A square.
R square plus A square. Correct, Krishna. See, this will be KQ divided by R square we have. What is R over here? Yes, Kulsum, you tell me, what is R over here? We have this formula of electric field, no? K Q by R square. K I have written. Charge is Q that I have taken. What is this R? Yes, Kulsum. Point and the separation from the charge. What is this distance?
E minus Q.
This E minus Q is the electric field. If this is minus Q, this is point C. What is this separation? This you have to take whenever you are calculating electric field, whatever, what is this R that I have written? KQ divided by R square. R means separation of the charge to the point that we are considering. So charge is this, point is this. We have just taken out this. What was AC?
Root R square plus A square.
R square plus A square. See, Kulsum, this is R, this is A. This is the triangle that I have drawn over here. This is R, this is A. So this gives under root R square plus A square.
Understood.
Okay, so this is the separation from the point to the charge. So now considering the electric field, we have to take under root r square plus a square to the whole square, which makes it kq by r square plus a square only, because root will get cancelled. This is to the power half and this will get cancelled. Tell me, is it fine till here?
Yes, ma'am.
Yes, ma'am.
All right. Now see, now if I tell you, because see, we have two axes resolved, we have resolved it in two axes. One is at the y-axis, other at the x-axis. So let us solve the net field along y-axis first. That will ease our calculation. So EY. Yes, Hamza Sheikhani. Hamza, you tell me. What are all the electric fields on the y-axis? What all electric fields are on the y-axis? Yeah, your mic is not working, so you can write me. Okay, Hamza, at least try. See, y-axis means this axis. This is your y-axis. All right. We have resolved electric fields in y component, in x component as well. This was our original electric field. This was our original electric field. So we have resolved them. E minus q cos theta, E plus q cos, E minus q sin theta. Then we resolved E plus q as E plus q cos theta and E plus q sin theta. Hamza, first tell me, is the resolution clear? Is it clear till here that how we have resolved the vectors? Yes or no, Hamza? Hamza, is this audible to you? Are you able to hear? All right. Hamza, tell me, is the resolution clear? How we have separated sine theta and cos theta? All right. Now see, Hamza, if this is clear, then your identification is easier. This is your y-axis. I'll draw it separately. Then you will be able to understand. See, E minus q sine theta is over here, means in the downwards direction. E plus q sine theta is there. This is your y-axis. This is E plus q cos theta, and you have E minus q cos theta. This is what we have resolved using resolution of vectors E plus q and E minus q. This is your y-axis. So what is there in the y-axis? E plus q sine theta is there and E minus q sine theta is there. So net electric field will be given by what? In the y-axis, only E plus q sine theta and E minus q sine theta. Now is it clear to all of you?
Yes, ma'am.
All right. So net electric field along y-axis, this is given by E plus Q sine theta minus E minus Q sine theta. And since we have seen the magnitude will be same, that will be KQ divided by R plus A square. So this will be 0. So EY is 0. There is no net electric field along y-axis. This you can easily identify through the figure also. Both of them are acting in opposite direction and have the same magnitude. So this will get cancelled. What is left? Net electric field along your x-axis is left. So net electric field along x-axis will give us the electric field. Net field along x-axis. Now see, this will be Ex will be E plus Q cos theta plus E minus Q cos theta. So this becomes what? This simply becomes 2E cos theta. Now we have to substitute cos theta also. We don't require cos theta. So let us look at this triangle again, AOC. This is theta. I'll draw the triangle once again. This was the triangle. This was your point O, this was your point A, and this was your point C. C point we are calculating. This is your R, separation from the center of dipole to the point. Half of dipole is taken as A. This separation is under root R square plus A square, and this was your theta. So in triangle AOC, just tell me what will be cos theta.
Cos 45?
No, cos 45 values you cannot get. Just tell me in terms of the things that you have. R, A, under root R square plus A square.
A by
A-
R
Yes,
square plus
Mariam?
A square.
Yes, correct. See, cos theta is what? Base by hypotenuse. Base is A. Hypotenuse is your under root R square plus A square. So we have cos theta with us. What was electric field? Electric field was KQ by R plus A square. Now we can get the resultant field. See, electric field due to Y is 0. So means net electric field is whatever is given by X only. So net electric field or resultant electric field will be KQ KQ by R square plus A square 2E, and instead of cos theta we have to write A by under root R square plus A square. Now R square plus A square, this is to the power 1. See, R square plus A square is to the power 1, whereas R square plus A square here is to the power half. So this will be R square plus A square to the power, anyone?
3 by 2.
3 by 2. These will get added, 1 plus 1 by half. This will be 3 by 2. So you have 2K you have K Q 2A divided by R square plus A square to the power 3 by 2. Are you able to identify dipole moment? In this formula, can we take out dipole moment? Is it possible?
Yes, ma'am. Q2.
Yes, ma'am.
Correct. This Q into 2A is the dipole moment. So this becomes Kp divided by R square plus A square to the power 3 by 2. This is your formula of electric field at the equatorial point. This same formula had 2 in it with the denominator change. That was for axial line. This is for equatorial line. Now, if you apply ideal dipole approximation, that is valid here also. Ideal dipole approximation basically means what? Your size of dipole is small. Your size of dipole is small. So it means that the separation between the two charges is very small, whereas the separation from the center of dipole to that point, this becomes large now. So it means your R is very, very greater than A. So this that we are having, R square plus A square, this can be approximately written to equal to R square only. It's like you have 1000 with you and you're adding 1 in it. That becomes 1001. So 1001 is approximately equal to 1000, means 1000. So if you have a bigger quantity and you're adding a very small quantity in it, will the larger quantity affect in any way? No, the larger quantity will have its own value. So we can equate R square plus A square as R square. So the formula was Kp divided by R square plus A square to the power 3 by 2. Now instead of R square, let me R square plus A square, let me just write R square. This becomes Kp. Instead of R square plus A square, what am I writing? R square to the power 3 by 2. So this half gets cancelled. Electric field at the equatorial point comes out to be Kp divided by R to the power 3. And see, this is again inversely proportional to cube of the distance. Electric field for a point charge was inversely proportional to square of the distance. One more thing that we do, whenever we write these formulas, we add a negative sign here or wherever we are writing, like here, we add a negative sign. This negative sign shows that if you remember for axial line, the direction of the electric field at the axial point was same as that of dipole. In case of electric field at equatorial point, the direction of dipole and direction of electric field are opposite. As in, if I have this dipole with me, this is the dipole minus Q, this is plus Q. Okay, Hamza, only Hamza. You tell me what is the direction of dipole moment here, towards the right or towards the left? We have done this a lot of time in today's class. Yes, Hamza. Is it directed, dipole moment is directed towards the right or towards the left? Negative to positive, that will be right. Both are correct. So both Hamzas have answered and it is correct, right? It will be left to right. Yes, from the negative to the positive. This will be the direction of the dipole moment. And if I give you this point, let's say P point, this is on the equatorial line of it. If the dipole is directed towards the right, the electric field will be directed towards the left because it is equatorial case. So this will be the direction of electric field. So for electric field, or if I tell you what is the direction of equatorial point's electric field, this is opposite to that of dipole moment. It is opposite to that of dipole moment. Whatever is the direction of dipole moment, just reverse it. That will give you. So since we have done a lot of content, I'll just write the summary so as you get clarification on what is axial field and what is equatorial field. So we have seen axial field, we have seen equatorial point as well. Axial point was when the dipole's axis had the point. Equatorial when it is perpendicular to the dipole. Then electric field for the axial we got as 2kp divided by r cube. I'm writing after using ideal dipole approximation because most of the times you get the questions in such a manner that you are required to use the ideal dipole approximation. For the equator, but remember it for both. If you have equatorial point for electric field at the equatorial will be kp divided by, it will be kp divided by r cube. This will be your equatorial point. So axial point is this, equatorial point is this. Direction, this is same as that of dipole. Here it is, the direction is opposite that of dipole, opposite to that of dipole. Now see, if I compare both of them, if I compare E axial with E equatorial, so if I take the ratio E axial by E equatorial, E axial is what? 2kp divided by r cube. E equatorial is kp divided by r cube. So kp gets cancelled, r cube gets cancelled, means E axial is twice that of E equatorial. So many a times you are required to write the ratio between E axial by E equatorial. So you can write the ratio as E axial by E equatorial will be 2 by 1, or E equatorial by E axial will be 1 by 2. So this is the summary of what we have done. Is this clear to all of you now?
Yes, ma'am.
Yes, ma'am.
All right. So just note down the points of equatorial line as well. Axial you all have written, no?
Yes, ma'am.
Okay. Write it for dipole on equatorial line.
I'm finished.
All of you?
Yes, teacher.
Yes, ma'am.
Yes, ma'am.
All right. So let's do a question on this. Easy question. Formula based only. So just note it down, note down the question and try it yourself also. Note it down along with me. If you have a point A, this is the direction of the dipole that you have, first dipole. This is the direction and this is the second dipole that you have. P1, this is P2. And this separation from the center of dipole to this point, this is our similarly center of this dipole and separation. This is again R. This distance, this is R. So write down whatever is the resultant of E1 and E2. Resultant electric field.
Ma'am, instead of 2A, should we take R? Because distance is R here.
Instead of 2A,
2A.
2A is the dipole's distance. No, we take. See, 2A is what? 2A is the separation of the two charges, right?
Yeah.
All right. Here, this is giving you that point that we take from the center of dipole to the point. The R that is included over here. This R.
Okay.
This R cube. All right, that is given to you. See, you have two values. One you have 2A, other you have as R. So I think Z, you were not there when we were discussing that. A2A is the separation between the dipole. This is minus Q1, or let me show it to you in axial. This is better. See, 2A is the separation between the two charges, positive and negative, means the length of dipole is 2A. This X or R that I have given you in the question as well, this is the separation of the point to the center of dipole. So whatever in the answers that we are getting, R cube, or in when we wrote about axial, we wrote X. So that is your center separation to that point. All right. 2A is the
Yes.
dipole's length. So you don't need dipole's length right now. When do you require dipole's length? When you have charge and dipole's length, so you calculate the dipole moment. Dipole moment is provided to you. P1 and P2 are there. You just have to take out whatever is the resultant electric field.
Okay. Thanks.
So I think let us all discuss it together only. So yes, Z, you tell me, is the point A with respect to P1 dipole? Is it axial case or equatorial case?
It's according to me, it's axial.
It is axial. According to you, it is axial and it is correct. See, just extend the line, means just extend the axis of the dipole. This point is line on the axis. So this means this is the axial point. Aisha, you tell me what is the direction? Just look into your notes. You must have written it down. For axial, is it along the electric field and dipole are in the same direction or opposite? Aisha.
Ma'am, same direction. Oh.
Ma'am, it's in
Oh. Yes, Aisha.
same direction.
Same direction. So if the direction of dipole moment is this is what is given to you. This is your A point. So Aisha, you only tell me, electric field is directed towards right or left? This direction is towards right or left for dipole? It is directed towards, just look at the arrow tail.
It's towards the right.
Right. So see, electric field will also be towards the right. So this will be the direction of electric field E1. Is it clear, Aisha?
Yes, ma'am.
All right. Okay, Akifa, you tell me for P2, is point A on the axial of it or equatorial of it?
Axial.
Axial, correct. See, just extend it. Just extend the axis. Had the point been lying over here or over here, then it would have been equatorial. This is again axial. So direction of dipole moment is towards upwards. So direction of electric field will also be upwards. Mean electric field will be in this manner, directed upwards. This is E2 that you are getting. So you ultimately have E2, you have E1 with you, and your resultant at this point, this was A given. EA we have to find out. So see, EA will be given by what? Using your superposition principle, you can easily say EA is given by vector sum of E1 plus vector sum of E2. You have to add them vectorially. Now, or for both of them are axial, and at axial we have seen it is Kp by RQ. This is electric field for axial. Had it been equatorial, we would have taken only Kp by RQ. So this will be 2K. Which P will I take for E1? P1 or P2?
E1.
P1 only, no. You don't even need to think in this. Electric field is because we are considering E1 because of dipole P1. So P1 will be taken. 2K P1 divided by R cube. And the direction. Yes, Fatima, tell me what is the direction? Is it I cap, J cap, K cap? For E1, what is the direction? Which?
I cap.
I cap. So this will be 2K P1 R cube by I cap. So I have written it for E1. All of you write me in the chat box this same whole formula for E2. What will it be for E2? This is the dipole that you have. Z, write the whole term. The way I've written 2K, whatever P will come divided by R cube. And then your unit vector. Whole term, everybody. Not only Z has answered. All of you answer. Akifa, right? Fatima, Hamza, Hiba, Krishna, Kulsum, Mariam, Aisha, you also try. Fatima, unit vector is missing. Fatima, Munir, yours is correct. Yours is right. Krishna, just check your unit vector once again. Akifa is correct. Correct. Kulsum is also correct. Fine. Correct. Mariam is also right. So Mariam, Fatima, Kulsum, Akifa, Krishna, Fatima, Munir, Zaid, all these have answered. What about rest of you? Hamza? Hiba. See, from the general formula, 2 will come. K is a constant that will come. E2 has been generated because of this dipole P2. So P2 will come. So this will be P2 divided by R cube. Regarding the unit vector is positive y-axis because the electric field E2 is directed towards the positive y-axis. The unit vector for positive y-axis is j cap. So this becomes j cap. This is your answer. And in the question, if you are provided with different values, just write all the values that are given and solve it. So clear? Will you be able to identify equatorial, axial and solve it?
Yes, ma'am.
Yes.
So just note down all those who have not written.
Ma'am, can we take anything common from here?
We can take common. 2k divided by r cube is already common. So it will be p1 I cap plus p2 j cap.
Okay.
So all those who have written, you can log out now. We'll continue in the next class. This completes your dipole moment. So we'll begin with a new topic in the next class. All right.
Thank you, ma'am.
Thank you, teacher.
Thank you, ma'am.
Thank you, ma'am.
Okay, most welcome.
Thank you, ma'am.
Okay.